Good morning, and thank you all for joining the webinar. As a longtime customer and HOMER user, I've come to depend on HOMER to conduct the techno-economic analysis that we all need to help define our architectures and system configurations, and then ultimately deliver winning proposals to our clients. So when I heard that HOMER was launching a new EV charger module and that we would be able to apply the same platform to electrified transportation, I volunteered to join the beta team as an advisor, and happily they accepted. Before Steffi provides a detailed view of the module, I thought it would help to cover a few of the motivating factors as to why the EV segment is growing, along with some of the infrastructure-oriented challenges that are being overcome, that are being mitigated, and those that are going to accelerate the adoption of EV transportation and, of course, the EV charging infrastructure itself. Next slide, please. Right. Generally, there are two factors driving the adoption. The first one are policies and regulations, and then the second category is customer demand. From a policy and regulation perspective, fuel economy standards, emission targets, financial incentives, and driving factors has matured the segment to the point where every major country has some policy that eventually is favorable to or specifically requires EVs. For example, in the EU, the CO2 emissions requirements for fleet vehicles require EVs. And in this way, along with Copenhagen's diesel passenger requirements and light duties that have been banned, or Paris's low emission zone, or London's zero emission zone, or Beijing's road space rationing, which favors EVs. The list goes on until 2030, where most fossil fuel vehicles are just going to be banned outright in such cities. And we ought to see EV share reaching 10% in 2025 and 22% in 2030. Next slide. The second major factor driving update is customer demand. Look, if you drive an EV, then you know the performance is amazing. The costs are considerably lower than ICEs. It's another way we can be better stewards of our communities. And then, of course, they're just super fun to drive. So the numbers are also telling this way. As we exited 2019, there were over 2 million EVs on the road. And by 2030, the estimates are in the 21 million range, capturing 20% of the total market share. These are the numbers for the EV side. Then I just read briefly from Wood Mackenzie or GTM that they expect somewhere on the order of 30 million EV chargers to be installed at the same time. I'm not sure of the breakdown between level 2 and DC fast charging, but still, this is an incredible opportunity for all of us, even if it also means that there's a bit of a race to identify some of the convenient fast charging locations. Lastly, the IEA, or the International Energy Agency, published a very good EV outlook a few months ago, and it's about 225 pages long. I thought it was a good read. Maybe it will be for you as well. I'll post the URL to this report in the chat box in a few moments. Tricia, next slide, please. So if these were the motivators, let's also discuss some of the concerns and some of the challenges. Driving range, cost premiums, charging infrastructure serving both destination and convenience stations, and then, of course, the time to charge. Range, that's an easy one. In 2020, every major EV manufacturer is going to support vehicles that can go 250 miles, and right after that, higher still. Price parity, we're already close to price parity today on a total cost of ownership basis. And then looking at the incentives from now till 2024, certainly at price parity. Charging capacity and coverage, I'm going to cover these on the next two slides. Next slide, please. Charging capacity and coverage, or charging infrastructure and the time to charge. Let's put this into some context. Next-gen EVs have a greater energy density, hence larger capacities to go further distances, and DC fast charging makes it possible to charge them quickly. For example, Audi's new lineup is a 60 kWh battery or car that'll be able to charge 80% within 30 minutes. But what this also means is that more EVs can be supported overall. So these two challenges can, or also being overcome. That said, what it also means is that the ability to charge more vehicles faster with greater consumption per car is that we need to pay significantly more attention to the charging infrastructure at a local, at a utility level, that we manage our resilience strategies, especially in business critical applications, and or we simply to continue to give us drivers a great experience. That we also make sure we're right sizing our DERs, or distributed energy resource strategies, such as solar and storage, to offset the load, to manage the spikiness of the load against tariff rates that may or may not have peak demand charges, all of which requires that deep techno-economic analysis and comparative analysis that HOMER provides. This last part regarding tariffs is evolving, and a good lead into the next and last slide. Next slide, please. Okay, so this is the last slide before passing the mic to Steffi, who's going to present a first of its kind live demo. I could spend an hour plus on this application and how the numbers were derived, but here are the results of a current DC fast charging depot project supporting an average fleet of 10 50 kW chargers located in LA or Los Angeles, with some reasonably regular day-to-day 15-minute load intervals using the new HOMER EV charging module. How did the process work? As normal, first, created a load profile against a fleet of 10 fast chargers. And what was cool about this is I didn't have to go looking for a profile that frankly didn't or doesn't exist. And I didn't have to create an overly complicated Excel algorithm to generate a load. HOMER let me create that load, calculate the consumption, the energy consumption, and the peak demand, and then introduce load variability with a couple of cool options. In this case, the annual energy consumption is expected to be about 2.5 million kilowatt hours. Then I added the current utility rate, or rates in this case, with both TOU, or time of use charges, for both, one with peak demand charges and one without. GS3, or SoCal Edison's GS3 rate, has demand charges, and the new series of EV chargers from SoCal Edison, amongst the other utilities in California, don't. This one is EV8. Then I added solar, I added storage, determined what kind of savings could be achieved by including the DERs. All, of course, was bounded by the interconnection constraints, not wanting to add any more high voltage lines than necessary, the physical constraints of where the solar carports are located, where the stationary storage would be located, and to make sure that we capture the ITC for the first 5-year period by making sure we charge the batteries from the solar array, all the while making sure that we keep the battery cycling in check, especially on the lower states of charge, to avoid any sort of accelerated capacity fade or degradation. I ran a number of cases in just a few minutes, varying the size of the array, the capacity of the battery, and the optimal results with just energy shifting arbitrage and peak demand charges are to include a modest amount of solar car parts, about 100 kW, and a 200 kW battery at 2 hours, or 400 kWh on the storage side. It may help to know that the client is currently on a GS3 rate, and so I baselined the expense profile without the DERs, and that has a $284,000 expense on energy, a $44,000 expense on demand charges. The total is $328,000. It's the demand charges that are a killer, and I suspect you all know that. Not only is it 20% of the total expenses, but one, it's the portion of the bill that's historically been escalating the fastest. And if you do a look back over the last 10 years for that rate structure and for demand charges, it's pretty close to 9% per year. And so it's possible to see that this part of the bill could be 30% or even more in the not too distant future. So applying energy shifting arbitrage and peak charge reduction, we achieved a $50,000 year one savings, and the after-tax unlevered IRR on that savings module is about 16%. Then I did exactly the same thing with the new commercial EV tariffs, EV8 in this case. It's separately metered, it doesn't have peak demand charges, and you can see we can now capture even deeper savings for an additional $50,000. I probably should have noted a moment ago that you'll see that the peak demand is 495 kW. This was intentionally capped to be just below 500 kW for the simple reason that we didn't want to be kicked into the next rate structure, which is EV9, and that starts at 500 kW, but it's also more expensive. Homer let me do this. This one, the EV8, has an IRR of about 22%, and that's more than significant. I did include SGIP, or self-generation incentives, but I didn't include demand response, or DR, just for simplicity and to leave this as an option for financial upside and potential for our client. Both of which, SGIP and demand response, could have been performed inside of HOMER, either the existing module and certainly the EV one. Hopefully I've shared some useful perspective on why the market's growing so quickly from 1 million to 21 million, or a 20+ fold increase in a new institution. Electrified transportation is pretty impressive. That we also get to include greater purpose to reducing greenhouse gases in our business practices is also exciting. Some of the challenges that are being managed, if not completely mitigated, and how the focus is or ought to be on carefully managing and designing the charging infrastructure with highly skilled tools that are referenceable and easy to use, ultimately making it that much easier for you, your colleagues, your clients, my clients, to participate in this growing economy of electrified transportation. I'm going to pass the mic off to Steffi, and we'll be rounding about if you have any questions at the end. Thank you.
Thank you, David, for the introduction. So I will be giving a software demonstration of the EV feature, and specifically I'll be comparing a firm charging requirement to a managed charging application. And so that we're on the same page, sometimes I may refer to the firm charging application as an on-demand EV charger, and I may refer to managed charging as a smart deferrable charger. So for my purposes, those terms are equivalent. Next slide. The EV feature is new to HOMER Grid, one of the two products, main products that HOMER Energy by UL offers for its desktop application. And HOMER Grid is specifically designed for modeling the grid-connected systems behind the meter systems. A dispatch algorithm that models demand reduction as well as offsetting utility bills through self-consumption and energy arbitrage. Finally, it has the ability to model the value of reliability and resilience for grid-connected systems. So HOMER Grid can help you find the lowest cost combination of solar, storage, wind, and a generator that will meet your energy needs. Ultimately, it helps you test different scenarios and design a system that ensures that your energy demand is met by generation sources. And as of today, version 1.8, your energy demand can include this additional load that an EV charging station requires. So just to summarize what HOMER Grid offers, the fast strategy that I mentioned has the ability to stack value streams like demand charge reduction. It offers the ability to dig deep into the details and understand the risks around project assumptions. And ultimately, it helps you create beautiful reports and graphics that you can use to assist your potential clients and counterparts. We make it easy to model PV and wind production by offering built-in reuse data and a library of tariffs for North America. If you're not in North America, or even if you are and you need a custom tariff, we have a Tariff Builder in the library feature, which allows you to any kind of tariff that you need. And our specialty is really around our storage modeling, so we can accurately model how storage lifetime by wear and cycling and temperature degradation. HOMER Grid can model CHP systems, and now we are showing you the ability to model EV requirements. So specifically about the EV requirements. This is HOMER's first EV feature, and the world of EVs is very large. There's different aspects of EVs which could be of interest to you, and we would love to hear your feedback. For this first release, we're modeling two specific things. The first is a firm on-demand charging load, and that would kind of cover the convenience charging application where the car shows up and it must be charged. End of story. The second is a managed EV charging load or a smart deferrable charging requirement. And for this, the car is parked and may be charged at any time during which the car is there. So it's up to HOMER to decide when during that time period to charge. So these two charging strategies represent a range of charger technologies, including Level 2 or DC fast charging. And you can model as many chargers as you need and a combination of these dispatch strategies, charging strategies. And one thing to remember is that this feature is a savings model, so it shows you how to meet the EV load at the best lowest cost. It is not a revenue model where the charger has a revenue stream based on the energy served to the EVs. And similarly, this feature is also not meant to vehicle-to-grid or vehicle-to-load applications, but we would really love to hear your feedback about this. We're excited to offer our initial EV features, and we want to hear your opinions. So feel free to type your feedback into the chat function or send an email to our support team. And with that, I will introduce our first case study. So we'll be modeling a hospital in Long Beach, which is considering converting its fleet of ambulances into electric vehicles. And as David kind of set up, the hospital is on general tariff. However, with this EV charging station, there's the opportunity to do that as a sub-metered system and use a specifically designed EV tariff. And so we'll compare which is more cost advantageous. In this first example, the ambulances arrive during the day and need to be charged immediately, and we'll consider 40 chargers, each with 150 kilowatts of output. And so that's DC fast charging. And we'll use kind of the same setup for our managed charging application to compare. So with that, let's go to HOMER Grid. All right, so you may be familiar with this tool, but I'll run through how to set up a basic model. The first thing you do is work your way down the left-hand side. So we are on the setup page where we define our location. Our location is Long Beach, and we can easily pull the resource data from the libraries that we have. Or you can upload your own resource data. That's obviously the best. If you have measured data, that's great. You'd go to the resources option here. We can set up some high-level economics and then continue down this left-hand side. We won't consider the hospital primary load today. We'll just consider the EV load. So we'll skip that. And under utility, this is where we can define our different tariffs that we're on. So in the zip code, we're pulling from the tariff database. I'll pull the relevant tariff using our filtering tool. And we're going to GS3E. All right, so this is the tariff that the whole hospital facility is on. And we've put a lot of effort into really building out this tariff interface so that you can fully understand what information is coming over from this database. So by clicking through these tabs here, you can understand exactly what rate does the database have for on-peak summer, on-peak winter, and you can verify that that's all correct by going to the tariff app. That should link to the actual PDF that this tariff is based on. So that's a great way to get confidence your basic inputs are correct. And this tariff database is a great tool to help you quickly get started just by choosing the name of your tariff. If you would want to build a custom tariff, you could use the library feature in the upper right-hand corner. So this is our first tariff, our general tariff that we're on, and now we'll consider what would our EV tariff look like. And we'll consider time use EV8. So similarly, we can go through and understand exactly what information does this tariff include and how does that affect the utility bill. So what's our base case situation? So it's good to take a minute and get confidence that this utility plus load system matches up with your utility bills, because that will be the foundation upon which your other compare economics calculations are based off of. Continuing down the left-hand side, we've already set actually my PV. I'm testing 50 kilowatts, 100 kilowatts, and 150 kilowatts for this system. And our storage, we've chosen to consider 1 or 2 batteries and define costs here with capital replacement and operational costs. There is a whole host of other metrics which define a battery, and that is what you can see through the library application. And you can create your own custom components for any of these, PV or storage or generator, and use that in your model. So it's hard to get certain manufacturers or a good portion of manufacturers into our list, which you can see in this catalog. However, you are of course welcome and encouraged to create your own models. So with that, I've set up my PV and my storage and my converter. And now we will skip through the EV charging load. For this case, I've set up an example of the firm charging. So this is a library of examples that you can choose from, and bold means that's my personal library. So this firm charging requirement, we're going to have, so the first thing that you define is your charger specifications. So the charger output power is max of 150. We're considering 40 chargers. And then you'd go on to find what the usage profile is. And we can do this month by month and different for weekdays and weekends. So you can see in this heat map here that during the day, there's more ambulances that come and need charged, which makes sense. And in this example, it seems to be, I can't really see any weekday, weekend differentiation. What I've defined is 100 charging sessions per day here. And the sensitivity button will allow me to test what would happen if it was actually 120 charging sessions per day. What would happen if that was 80 charging sessions per day? Would my ultimate system design change based on those parameters? And finally, what you'll need to define for this EV charging feature is the vehicle type. So in this case, we're just considering one generic EV ambulance. That is 100% of the population. It has a max power, which is actually equivalent to the charger output power. It doesn't need to be, whichever is the limiting factor is what HOMER will take. And on average, you charge for 50 minutes, 150 kilowatts. So with this, this is defined basically our EV load, which is non-flexible, which is firm requirement. And HOMER can give simulations which meet this load. So with that, let's go to looking at the results. And I pulled up an example already. So this is the results that we've calculated from that file. As you can see, we're comparing the general tariff and the EV tariff. And the EV tariff is a cheaper tariff for this use case. So you can see that the systems are sorted by net present cost here. HOMER optimizes on net present cost. So the systems presented are going to try and achieve that lowest net present cost. You can look into any of these details further by double clicking on them. So we can look at this battery system for the firm charging requirements. And the details will show you a cost summary, your cash flow, which you can then export into Excel and further do post-processing or whatever you need to do for your financial models. We can compare how the hybrid system is more economically advantageous than the utility-only system, and see how the electrical or production sources are meeting the demand here. And for each component, you'll be able to see exactly how that is operating. So this is engineering details that HOMER provides. Finally, our eevee feature, this is the load that we had set up, and charging sessions per year, average energy per session. That's all outputted here. If you wanted to see specifically what is happening time step by time step, or how is this eevee load being served, we can go to this time series viewer. And you can customize this completely. There's all these data series here. So we can look at the total eevee charger served. And that's served by a combination of grid purchases and the storage on the bottom. And finally, it may be interesting to see, is the storage discharging in line with the consumption rates? So with that, I'll zoom into a specific day. I'll make this big. All right, so what we have here is our eevee charging load served. I'll make that a slightly different color. And the grid purchases. So largely this eevee load is served by the grid purchases, but the battery is able to charge and discharge, charge when the cost is low. So you can see the yellow state of charge rising as the price in purple is low. And as soon as the on-peak time hits, then the battery discharges. So this is how you could really get a feel for how HOMER is choosing to dispatch. And you can take this and put it in a report, and I'll show you that in just a minute. So the time series, there's other visualizations as well, but this is how you can get a good look into how the system is operating. I'll wait to show the report actually for our second example. We'll go back to the design view, and we'll start to consider what would happen if I was actually able to manage my eevee load. So we're back here. We've got our firm charging eevee load set up, and now we'll do a managed charging load. So I've set up the same charger specifications. We have 150 kilowatts, we have 40 chargers. Our ambulances require the same amount of energy. However, they are parked for an average time of 7 hours. Similarly, there's the same daytime profile that is heavier than the nighttime profile, and there's 100 charging sessions per day. And what I'm going to do here is I want to explicitly compare the managed versus the firm. I'm going to use our sensitivity feature here. This is pretty powerful. It's a little bit of an advanced tool, but you can test with 100 sessions per day or not managed at all. And you can link the sensitivities here. So we're going to do kind of with one or with the other, and we'll compare them. All right, so with that, we can go back and calculate. And because it will take a minute, I'll switch to calculated those results in advanced as well. All right, so what I'm showing here is sensitivity analyses are shown in the upper table. So the top one is the managed charging application, and the second is the firm charging application. And by clicking on each of them, you'll notice the lower table changes. That's choosing which sensitivity variable you'd like to consider. So for our managed charging application, notice at a high level, you can compare the winning system, which is the storage system, to the winning system of the other activity. And you'll notice that there's a dramatic decrease in net present cost if you are able to manage your EV load. So 8.32 million versus almost 6 million. It's a great savings, and you can see the cost of energy in that as well. So considering that we want to further investigate this managed case, we'll go and look at this battery system. A PV system is also a great way to save money versus the base case, and it's interesting that yeah, either PV or either storage alone actually provides the lowest net present cost here. So looking at this battery system, this is our simulation results for that simulation, and for this EV, we're looking at a managed load. You can see the high level information. And what's really neat about this managed load is you can get further information about, okay, so we have 100 sessions today. On this day, we have 101 sessions. And you can see for every single individual vehicle that arrives, how is that vehicle charged and when is that charged? So you can see the different colors are the different vehicles arriving, and so there's them, so it looks colorful if not overwhelming, but it's beautiful. And you can really dig into the details about each individual session. So you could go to a specific car and say, okay, this car arrives at this time. This is how its state of charge varies over that time. And so you can get really into the details about how this charge is being served. All right, so with that, we've compared how the different tariffs provide different savings or costs. And we've seen how the hybrid system can ultimately reduce the net present costs for your system. We've compared the economic benefit of a managed charging application versus a firm charging application, and say that we've come to the point where we understand that we're going to go for a managed charging application, these two Tesla power packs, and now we'd just like to create a proposal. And Tricia mentioned that this was new as of January. So we have two different proposal types. There's kind of a detailed report, which has been included in a HOMER for a long time, and this client proposal, and that's new. So for the client proposal, it's more focused on communicating the details of the simulation in a beautiful way to your respective counterparties. And set the client information. It's also about showing yourself in good light, so you can set up your own company information, company testimonials, your logo, all of that can be customized and it'll be saved to your user settings. So you only have to fill it out once. Finally, you can completely customize the report that comes out by choosing to include or not include sections in the report. And you can also change the order just by dragging and dropping. So you can, right now the report is in the docx format, and we'll open that up. And here's what you'll ultimately be able to get and use and further customize to your needs. So just quickly, we have great looking setup, your customer testimonials, high level information about the product, and then ultimately, how does this system save the hospital money? How is this the lowest cost system? That you can, further explore the different features that we have. As Tricia mentioned, this is in beta, so I really encourage you to check it out. Tricia, I'll go back over to you. Well, just some takeaways. As we kind of mentioned before, what we discussed was comparing two tariffs, how the EVA tariff has a lower lifetime cost than the general tariff, how managed charging requirements can lower your NPC by 30-some%, and how ultimately HOMER is designed to find that lowest optimal, lowest cost system. that can meet your facility's energy demand and EV charging requirements. All right, thanks, Tricia. Back to you.
Thank you, Steffi. So now we'll want to go to questions. Thank you both Steffi and David for a very informative presentation. We will have a lot of questions, I'm sure, and while those are streaming in, I wanted to address one question that often comes up. We recognize that there is a learning curve when using HOMER software, so we offer services like premium support and consulting, so we can help you get the results that you need. If you need HOMER for just a few projects, we can do the work for you. And if you need it for many, we have a number of training classes that we recently expanded, or we offer premium support. So whether you are an individual or you need to get training for a team, we can set you up with the best support solution. You can explore our training sessions at gethomertraining.com or contact us through support@homerenergy.com. So let's go ahead and go to questions now. Marilyn Walker, the co-founder of HOMER Energy, has been collecting questions as they've been streaming in. Marilyn, what do you have for us?
We have lots of great questions. So first, just this one always comes up, is this being recorded and can I get the slides? Yes, it's being recorded. Since this was a live presentation of the software, there aren't really slides available, but we work right away to try to get the recording out to you. So this is absolutely going to be available to everyone. Okay, lots of questions, so I'm going to move kind of quickly. Steffi, does HOMER Grid work only in North America? What about other tariffs?
No, absolutely. HOMER Grid works around the world, and it works for any application that's really, where the value is centered around demand charge reduction, where that's a key value stream. You can create your own tariff with the Tariff Builder that we have in our library feature, and that can include very complex tariffs with tiered rate structures and ratcheted rate structures and contracted demand. You can really build up almost any tariff that you can possibly imagine. And if you have any trouble, actually an annual license for HOMER Grid does come with 2 hours of premium support, and so you can work with our support team so that we get the tariffs right together. So I understand that the tariffs are an important part. Yeah.
Thanks. So can I modify the converter design or the converter behavior per my requirements?
Sure, yeah. Like any of the components, you can create your own custom converter, and you can set up a specific efficiency table. Everything like that will be in the library feature.
Great. How about HOMER Pro? There's lots of interest in HOMER Pro. Is there any plans to add this to HOMER Pro?
Well, that's actually what we would love to hear feedback about. So for the application that HOMER Grid was designed for, it's kind of the grid connected application where you're focused on how to reduce utility bills. So the use of EVs is really more, there's more synergy with HOMER Grid, but we would love to hear what you think. And yeah, looking forward to hearing your feedback.
Great. Yeah, and maybe this is kind of a good follow-up, and I'll answer this one. People are saying that they tried the HOMER Grid trial version before. If you've done a trial and you want to get on there now and you don't have a HOMER Grid license and you want to try this EV charging, please reach out to our support team, support@homerenergy.com, and they can help you get a new trial so you can try this out. Okay, how about getting some questions on libraries, Steffi? Tell us about the library. Is there a library of EV chargers similar to the solar and storage libraries?
Yeah, so the kind of drop down that I selected is how our EV library works right now. So you'll design kind of an example, which is a combination of different EVs and their charging requirements and the load profile or the usage profile. And that can be saved and stored into your library, and it will show up in bold in that drop that I showed. And we have some examples, which includes like various different EV specs to them and charger specs to them, and we have it on our road to expand that list out for you as well.
Great. Okay, I'll do a couple more for you, and then we're going to give you a break. But lots of interest in VehicletoGrid. Can you talk about, what are the plans? Where does that stand on the roadmap? Is it on the roadmap?
Yeah, well, as I mentioned, this is our first EV feature. So VehicletoGrid is a very exciting new market that I think there's a lot of interest in. And so we will take your feedback and incorporate that into our at this point. Things are around kind of managing loads, and so these features were definitely chosen to be our first steps, but we are considering VehicletoGrid applications as well.
Yeah, thank you. Yeah, I just want to follow up on that, and just to say, to my knowledge, this is the first software tool that's really looking at optimizing how to add solar plus storage to really optimize your vehicle charging. So we're very excited about that. We're going to see how this goes. And yeah, so on that note, because the market's still evolving, but David, I would love to hear from you on what do you think are 1 to 2 things that could, really make a difference, maybe policy-wise or political will-wise in pushing this forward?
Sure, it's a good question. Policy is, that's a pretty broad topic. Maybe I can narrow that down to something that's a little bit more tangible for all of us, and that's really related to the rate structures. At the moment, there's really only one region that has commercial EV charging rates, and that's California, that I know of anyway. And the reason why that's important is those commercial rate structures largely don't have demand charges, at least for the next 4.5 years. That's actually a really big component in managing the financials, managing the architecture and the configuration, because they do comprise, when demand charges are present, they do comprise a large part of the bill. So California, at least for the next 4.5 years, for those rates, does not have demand charges. The commission has not said what the demand charges are going to be after this holiday period. We hope that they're small. There's also a good report from Rocky Mountain Institute, or RMI, that was working in collaboration with Xcel Energy for some rate designs or rate suggestions, and they too said that some amount of demand charges are okay in the sense that they drive a certain amount of behavior, but not at the level that demand charges exist in the other rates. I'm going to point to rate structure and rate analysis as being probably the biggest number 1 and number 2 item.
Great, thank you. Yeah. So on that kind of follow on then to you, Steffi, does HOMER manage yearly demand charges? What kind of structures does it look at?
So it has the ability to calculate tariffs that have daily demand, monthly demands, and annual demands. Really, the strength or the dispatch is designed around the monthly demand optimization. So how HOMER's dispatch algorithm works is that for every month, it's going to test for this artificial demand limit. It's going to see if I set my demand limit very low so that I'm buying very little from the grid in this month, does that produce a lower cost than if I buy all of my energy from the grid? And it'll find that sweet spot for every month. So that's how HOMER Grid does its demand charge reduction modeling, is by simulating how low or what is the sweet spot in net present cost for each month by changing this demand charge limit or demand limit.
Great, thank you. Does it matter if the chargers are level 1 or level 2?
You can effectively accommodate either in the feature that we have right now, and that would be modeled through the charger output limitation.
Okay, great. Is there currently or a plan for a library of car types? How does that work?
So at this point, it's included in that drop-down menu where you would see, yes, different car types and what their like battery sizes would be. And to complement that, you'll need to customize or add the profile of usage. So at this point, they're kind of wrapped together. But yes, there are examples of cars and their specifications in the library.
Great. Okay, I can answer this one. Is this an optional module for HOMER Grid? This is included in the base product. So HOMER Grid actually only has one module, and that is combined heat and power. Everything else in it right now, including the new MATLAB or controller API feature, the report writer, is all in the base product. Okay. Does the eevee module calculate IRR or NPV from the CapEx and savings?
Yes, absolutely. So it's calculating your payback by comparing the proposed system economics, including the CAPEX and the OPEX, to the economics of your base case system, or often the utility only system. And yes, IRR is definitely one of the metrics that we provide.
Okay. Let's see. Can we model plug-in hybrids in HOMER Grid?
Good question. To the extent that you can break out, well, I haven't thought about it actually. To the extent that you can break out the electrical component, yes.
Okay. Great. Let's see, one or two more. Yeah, there's several questions. I'll try to kind of combine them. It's talking about like randomized charging and actually says like, can you talk about how HOMER simulates EV load, including like randomness of start time and charge duration of each session? And I know you talked about that a little bit, but it's a lot to take in. So maybe go over that again.
Yeah, actually, I did kind of gloss over that. So HOMER Grid, it's going to model a random, so if you say one car shows up in the hour of, in the noon hour, it's going to do a random draw about exactly when in an hour it's going to show up. It does that by default. And then in addition to that, it can set variability, and it can be time step to time variability or day-to-day variability or the duration variability. So that's how you can introduce a more realistic profile into your model.
Great, thank you. Okay, I have an interesting tariff question that I don't know the answer to. So it says some tariffs have minimum or maximum peak demand. Will HOMER Grid tell the user if their load profile is not eligible for the tariff modeled?
So the database has the information about what is the peak or what is the min-max demand that this tariff is eligible for. At this point, HOMER doesn't give you like a warning or tell you that like, hey, you're wrong when you select a tariff that's not compatible with your load. So that could be something we could add in the future, but right now it's really up to you to, when you're choosing your tariff, look at what max and min peak demands that tariff is eligible for and make sure that that is compatible with your load. So the information is there, but you will have to double check it yourself.
Great. Okay. I think I know there's lots more questions coming in. There's questions about cost. There's questions about trials. There's technical questions. And I will just repeat that, support@homerenergy.com or sales@homerenergy.com are there for you. Steffi or David, if you had any last things to say, otherwise I turn it back over to Tricia to end the webinar.
So thank you so much for attending today's webinar. If you did not get your question answered, please send it through to your sales rep or our support desk, and watch for an email in a few days with a recording of this webinar. And we hope to see you again next month. Thank you.